1, number 1998, number 6, consider the curve defined. So this is what a related rate problem looks like on the AP exam. Okay, last year, or 2 years ago, they had a related rate, not a related rate, I'm sorry, an implicit differentiation problem. Here's what an implicit differentiation problem looks like on the AP exam. And they had one on there 2 years ago. They didn't have one last year. Last year it was on multiple choice. When they do it on multiple choice, they're only going to ask you to do one thing. They might say, just find the, they won't even say find the derivative implicitly. It'll just say find the derivative. And you need to know, because you can't solve for y, that you need implicit differentiation. 1 year they really tricked the students, because what they asked for, 1 year is they asked for dx dt, or they asked for dx dy, and it was set equal to y, and kids didn't realize they needed implicit differentiation, because you were actually wanting the derivative of x with respect to y. So you have to pay attention too, because they'll try and stump you. But on the multiple choice, it's always one thing to ask you to do, like find the derivative, and you do it implicitly, or they might find the slope of the tangent line. So they won't ask you in 3 parts like this. And this one's a little bit more involved, because one of these you have to really think a little bit on. If you want to move here, you can. I'll send around a sheet of paper in a second. So it says, consider the curve defined by 2y to the third plus 6x squared y minus 12x squared plus 6y equals 1. Show that dy dx is equal to this. So they're actually, here's the thing. What do you see in letter A that's interesting? The answer. They give you the answer. They literally give you the answer. So they're not interested in the answer. What are they interested in you doing? How to get it. Okay, the steps to get there. They're interested in, they're wanting to know, do you understand implicit differentiation? How do you know you need implicit differentiation in this problem? You want to find dy dx, so we do want to find the derivative of y. How do you know you want implicit differentiation? 2 variables. Well, not really. We got 2 variables all the time. Why? What about y?
You don't know what it is, so
You don't have it solved for. You don't know what y is. Okay? It's not y equals, and it would be really complicated to solve for y. If you could solve for y, do it. Okay? If you can solve for y, you want to do it. All right? But if you can't solve for y, then you're going to have to use implicit differentiation. And you have to recognize it on your own. So here's what it would look like. In part A, I think was around 2 or 3 points. 2y cubed plus 6x squared y minus 12x squared plus 6y equals 1. Here we go. First step, who wants to do 2y cubed for me? David, try it.
2y cubed.
Yeah, derivative of 2y cubed.
6y squared dy dx.
Times dy dx. Now the only thing we have to do implicitly is y. We don't have to do x implicitly, just y. Okay, so now we come to the next part. The next part's the hardest part of the problem. Okay, it's what makes the problem so interesting. What makes the next part so hard?
Use product rule.
You got to use product rule. And here's what I do. The 6, you got to kind of decide what you want to do with the 6. Do you want to treat it with the x squared, or do you want to treat it as a constant, a true constant, and just go? And that's what I'm going to do. If you do that, just put the 6 out front, and then now you're just doing product rule with x squared y. And you can distribute the 6 later. To me, it makes it a little bit easier. Now, some of you would argue, well, I want to keep it with the x squared because then I don't have to distribute it later. Fine, whatever floats your boat. I really don't care. It's not going to bother me at all. Okay, just pick a way, and I prefer this way, and I think it's easier to explain sometimes, but it does require you to distribute later. So derivative of x squared is what?
2x
2xy
plus.
Now, why didn't I do dx dy or something like that?
On the derivative of x now.
Because you're finding the derivative with respect to x, so you don't have to do an x implicitly, only y. Okay? So 2xy, derivative of x squared is 2x times y, derivative first times second, plus, I'm going to go ahead and just write x squared down. The first times the derivative of the second is what? dy dx. Okay? Next term, what would be the derivative of negative 12x squared?
You have 24x.
Negative 24x, and then plus, what's the derivative of 6y? 6 dy dx equal to 0. Now I want to stop right there because I want to make an important point here. That right there is worth 1 to 2 points in itself. I haven't got the rubric in front of me, but I know it's 1 point for sure, and it might be 2. Because what have you just demonstrated?
Found the derivative.
You had demonstrated that you understand implicit differentiation. Okay, you've demonstrated your ability to understand what it means to take a derivative of y implicitly. So that right there in itself is at least 1 point, if not 2. The last 2 points or 1.5 points, however they break it out, will come from you actually manipulating the equation and solving for dy dx. Since we're trying to prove something, you should show a little bit more work. You shouldn't just say, hocus pocus, there's dy dx on one side. You should at least do what?
Take out the
Get everything that doesn't have a dy dx to one side, leave the dy dx stuff on one side, factor out the dy dx, and then the dividing you don't have to show. So here's what I'm going to do. This is probably the amount of work I would show if I'm trying to prove something. I know I'm going to distribute the 6, so I'm going to leave, this has a dy dx in it, so I'm going to have 6y squared dy dx. This, when I distribute that, that's going to be 12xy. That doesn't have a dy dx in it, so I'm going to punch it over to the other side, so I'm going to leave that alone for a second. Just don't forget about it. Plus 6x squared dy dx. This one doesn't have a dy dx, this one does, so I'll leave that. Won't worry about that one for a second. And then you got the 6 dy dx left. Now, what got moved to the other side? Anything without a dy dx. So this is 12xy, so it's going to be negative 12xy over here. So 6 dy dx, so that's going to be minus 6. Okay, that was close. Minus 6 dy dx. Sorry. Thank you. Plus 24x. This doesn't have the dy dx. So these two things right here. Okay? Now what do? Factor out the dy dx and divide. Okay? So I'm going to factor out the dy dx. And some people are like, well, do I have to show that? I don't know. I don't know how. On the multiple choice, I know for sure you don't have to. But since we're trying to prove something, I'd be very wary about eliminating everything. So we got negative 12xy. Because now at this point, you don't have to show the division, so now we can just write our answer and divide off of what? Who sees what we're going to have to divide off? You're going to get negative 12xy plus 24x all over 6y squared plus 6x squared plus 6, which equals what? What did it equal? You guys are going to help me here.
4.
How can I get it to equal the answer? Divide off of 6. 6 divides everything. 6 divides this one, this one, this one, this one, this one. As long as it divides everything, you can divide off of 6 or factor out of 6 and cancel 6, however you want to say it. So that would make that, if I do that, make it negative 2xy. And if I want to rearrange it, I'm going to put that second, that would make that 4x, right? So we got 4x minus 2xy on top. And if you divide the 6's off on bottom, you're just going to have y squared. Or they put it in that order. We should put it in the same order they have it. Just to show, hey, we showed it. X squared plus y squared plus 1. There you go. Proved. So 3 points. And the only step of calculus you did is when? The only step of calculus you performed. First step, that was it. The only step you performed. Now, I think what's interesting about this free response is as you go, you wouldn't even need to know how to do part A to do part B and C. You could literally botch part A and get part B and C. Because they give you the answer, they give you the derivative, and that's what parts B and C is related to, is the derivative. So let's read part B. It says, write an equation of each horizontal tangent to the curve. What's a horizontal tangent? Come on, you guys just looked at your answer key and corrected your task.
It's
in
a
that
0.
question.
Right?
It's where the derivative equals what?
0.
Very good. You have the derivative. It's right there. So I just want to figure out where the derivative, dy dx, equals 0. Now your derivative is this, 4x minus 2xy over x squared plus y squared plus 1, and I want to know where that equals 0. Now somebody tell me, talk to me. When does a fraction equal 0? Only when the top equals 0. Only when the top. You don't care about the bottom. The bottom doesn't have to equal 0 for the fraction to equal 0. If the bottom equals 0, it's actually what?
Undefined.
It's actually undefined. What kind of tangent would that be? It wouldn't be a horizontal tangent. It'd be a vertical tangent, and they do ask you that. So if you ask for a horizontal tangent, you're looking for the fraction equals 0, and that'd be where the top equals 0. If you're looking for a vertical tangent, you're looking for the bottom equals 0 because you want to know where vertical line is undefined slope. Horizontal line is 0 slope. So We're looking for a horizontal tangent line, a horizontal slope, so 0. Now this is interesting because what you get is you get 4x minus 2xy equals 0. And you look at this and you're like, oh my gosh, I got two variables. What the heck am I going to do? Does anybody see anything I can do to it?
Can't you factor out an x?
Very good. You guys are thinking. It's very good. This is the kind of problems like you're going to try and walk me through this. You're going to factor out, I can actually factor out 2x if you want. So it's going to be 2 minus what? Y equals what? 0. So you get two answers. And what you're going to realize in a hurry here is if you look back at your original equation, you got a y cubed, you got an x squared. So it should make sense that you're going to get more than what? You're going to get more than 1 point. Okay, so when you start looking for horizontal tangents and something that has x squared and y squared, like we're not surprised when we get two x's when there's an x squared. But some of you might be surprised, oh, I got a y, interesting. All right, well that y, does that y go with that x? Not necessarily. So what we got is we got x equals 0, that's 1 point. But I don't know what its y value is. What am I going to have to do with this x equals 0? Plug it in to figure out its y value. And then this gives you y equals what? What does this one give you? Y equals 2, but it has its own x value, which I don't know what it is. I'd have to do what? Plug it in. So you've got this, you've identified the two places where the tangent line is equal to 0. There's a place where the tangent line equals 0, and it happens when x equals 0. And I can take that, plug it in, and get the points, and we're going to have to do that because they actually asked. Again, okay. This one right here, y equals 2, what they asked? They said write an equation of each horizontal tangent line. Oh, that's nice. This one you will, that one you won't. Because this is the horizontal tangent line. What do you need to get a horizontal tangent line? You need the what? You need the y value. Well, you got that one. So there's one answer, but now I've got to plug 0 in and see if there's other y values. Because then there might be other horizontal tangents. You can have a graph where there's multiple horizontal tangent lines. I'm trying to find that, what they are. So this one is one of the answers, so you can identify, okay, horizontal tangent lines. So I don't really need the x for this one. I could definitely plug y equals 2 in and find the x, but that doesn't matter. I don't need it. So we know there's a horizontal tangent at y equals 2. Okay? So now I'm going to plug 0 into the original. Here we go. 0 into the original. What's that going to give me? By the way, I know this was 2 points. I know this was a 4-point part. Part B was 4 points. I've done this problem before. I know where the 4 points come from. They give you 2 points for this. The last 2 points is going to come from the next part. And I'm going to show you how you get the last 2 points.
How many points is worth on the test? Like total?
For response, always worth 9. Always
No,
worth 9.
I mean, on the whole test, there's going to be 9 for response.
Now there's 6 for your response, so that's 54 points possible on the free response, and then you have a multiple choice section that's graded completely different. And I'll show you the formula they use to get your composite score, which converts to a 1, 2, 3, 4, or 5. 3's passing. Okay, so I put 0. So what is that going to give me if I put 0 for x? Remember, we always plug into where to get points? Original, okay? So if I put 0 in for x, what are you going to get? Use a different color.
2y cubed.
You get 2y cubed. What now?
6y.
Plus, are you sure? Yeah, sorry. This, what happens to this one? Cancels. What happens to this one? Cancels plus 6y equals what? 1. I love this problem. Because then we go back to I call it pre-algebra for you guys, but algebra, 9th grade algebra. What do you do to solve this? What do you do to solve this? You're going to love this. It's such a good morning. How do you factor? How do you factor something? What should you always do first? I'm going to scream to the top of my lungs here in a second. Always, always set it equal to. You don't ever do the problem when it's got powers in it without it set equal to 0. Because here's your 3 options after you set it equal to 0. And some of you are going to look at this and I'll be like, oh no, I know what option he's about to talk about. There's 3 options when you set it equal to 0. Number 1 is factoring. You should always try factoring first. But I'm going to tell you right now, factoring is out of the question because it's not in quadratic form. Quadratic form is power, half the power constant. I don't know if you remember me teaching that in the fall. Do you remember that? I did a whole spiel on the board one day, and I showed you 10 of them. I said if you have x to the 10th, the next one has to be x to the 5th, and then constant. This is y to the 3rd. What would the next one have to be? 3 halves, which I don't have. It's not a quadratic form, so guess what, ladies and gentlemen? This one's not factoring. So the second step is quadratic formula. Well, quadratic formula only works if it's in quadratic form. So guess what? If it's not in quadratic form, factoring and quadratic formula is not going to work. Does anybody know the last thing that will work? We did it as a warm-up 3 weeks ago. Starts with an S. Synthetic division. And the good news is on the AP exam, it always works fast. So what you do to do synthetic division is you multiply the first and the last, and you get a 2. And then you're going to try all the factors of 2. Plus or minus 1, plus or minus 2, plus or minus 1/2. Can I think of anything else?
No.
That's it. If they don't work, it doesn't work. I'll tell you it works, and it works right away. What should I try in the box first?
1.
Definitely going to try 1. So let me erase this. So we're going to put 1 in the box, which means we're seeing if y minus 1 or x minus, I mean, we got y, somebody used y minus 1. Usually it'd be x minus 1.
Why wasn't it negative 2?
Where?
2 times negative 1.
Because you're doing plus or minus anyways. Sorry, I had to track with you. You got to do the plus or minuses anyways. It is negative 2, but you're going to do the plus or minuses, so I don't care what the sign is. Okay? Then what do we put here? What do we put? Come on.
2,
Two.
0, 6.
Who said 0?
I did.
Thank you. Why do you got to put a 0?
Because there's no squared bit.
There's no squared. Okay? 6 and what?
Negative
Negative 1. All right? Let's run it through. Okay? 2. 2 times 1 is 2. 2. 2. 8. 8. Did that one work?
1. No.
No. Let's try another one. Should we go to negative 1? Negative 1?
Sure.
All right, let's do negative 1. That'd be y plus 1. All right, let's see if this one works. 2. Negative 2.
Negative 2.
Negative 2. 2. Does that one work?
No.
All right, 1 didn't work. Negative 1 didn't work. So what should we go to now?
2.
2. Okay? I think it works now. Times 2. What was it? 2, 0, 6, 1. Negative 1. All right, ready? 2, 4, 4, 8. Is this one going to work?
No.
No. Try negative 2. Bet this one works. If it doesn't, I'm going to look like an idiot. 2, negative 4, negative 4. Are you kidding me? That one doesn't work. What's another option?
1/2.
Huh?
1/2.
1/2. Gosh. 2, 0, 6, negative 1. This is stupid. Okay, 2. What's 2 times 1/2?
1.
1. That's 1. What's that?
0.5. Oh,
That one's not working. Somebody get a calculator out. This must be a calculator problem.
do negative 1/2.
Huh?
Do negative 1/2.
Am I missing something here? Like you. Alright, negative 1/2.
It's gonna work.
2, 0, 6, negative 1. Drop a 2. Negative 1. Negative 1. Positive 1/2. Don't know how that one's working.
Shoot.
Did I screw up 1 or negative 1?
Try it again.
Hold on. I have the answer key. I'm embarrassed. Let's see here. Okay.
What's the equation?
How embarrassing. What number is that?
6. 5. I don't know.
Huh, it was calculator. Wonder it doesn't work. No wonder synthetic division doesn't work. It's a calculator problem. You got 1 point for setting dy dx equal to 0, so you can see it. By the way, that was only 2 points up there. 1.3 plus the differentiation, 1 point for solving for dy dx. I thought it would have been 2 points. But this one's 4. I didn't remember that one. dy dx, you got a point for just knowing to set dy dx equal to 0. For understanding, that's what a horizontal tangent is. You get a point. You get a point for solving dy dx and getting dx equals 0 and y equals 2. So there's your 2 points. And then you get a point for using solutions for x to find the equations of the horizontal tangent. So when you put x equals 0 and you get this. So let me show you how to solve that. Take your calculator out real quick. It's real simple. I didn't know this is a calculator problem. That would have solved everything. If it's a calculator problem, you don't even need to think about factoring, quadratic formula, or synthetic division because it's going to require the calculator. So all you do is take and plug into your, it's up to you. If we set it equal to 0, there's 2 ways you can do it. There's 2 ways you can go about this. You could either take 2y cubed plus 6y equals 1 and solve it with your y equals, or you can take 2y cubed plus 6y minus 1 and set it equal to 0. So let me tell you 2 ways. If you do the top way, you're going to put this into y1, and you're going to put this into y2, listen, and you're going to see where they intersect. Because you're seeing whether those 2 graphs are equal. You're seeing where 2y cubed plus 6y equals 1. So you'd have the 2y cubed plus 2. So how about this half of the room do it that way? You guys put into y1, 2y cubed plus 6y.
How do you put in a y?
Go to y equals. Show them.
What do you do next? Oh, you just make this a y?
Yeah, oh, there is no y button. What button do we always use? The x button. Your calculator doesn't know if it's a y or x. It doesn't care. Okay, you guys are going to do it this way. I actually have it set equal to 0. So the difference is they're going to be looking to see where these 2 graphs intersect, but it's the same thing as setting equal to 0 and seeing where this crosses the what? So you're going to do second trace 0. So put in the y1 just the equation 2y cubed plus 6y minus 1 and then do second trace 0. You guys are going to do second trace intersect, which should be number 5. And what I want you to see is that regardless of which way you choose to do it, we will all get the same answer. Round the 3 decimal places, please. And I think there's only one answer, am I correct?
Yeah.
The answer is 0.1651. Round to 4 decimal places. If you know you got to use that answer for something else. I always say 3 to 4. If I know I'm using my answer for something else, I go to 4. So 1.654, is that correct? Everybody get it? Huh? Is it 5.1 or 5.4?
Yeah.
Right. Well, it's going to depend upon, here's what's going to depend, how close you got it. There's a little bit of error, okay? So, 5.2 you guys said? Okay? All right, so there's my y value. Were there any others? So we had 2 answers here. We had y equals 0.1652 and we had y equals 2. There's your 2 answers. Those are the 2 horizontal tangents. Okay? Part C, the line through the origin with slope -1 is tangent to the curve at the point P. Find the x and y coordinates of point P. So there's a line that passes through the origin and it's tangent to the curve. Okay, it's tangent to the curve and it has a slope of -1 at point P. Okay, so find the x and y coordinates of the point. All right, this is an interesting problem. And to save a little bit of time, you want me to work it out or just want me to show the answer key? Okay, so I can save some time so I can get to related rates since I had to waste my time on that other one. Let's see, hopefully I didn't minimize it. Here we go. So, what they did, actually that'll be hard to follow. Let me just explain it. Actually, that'll be hard to follow. I just realized. Okay, so what they did is they want to find a point P where it's tangent to this graph. So, in other words, dy dx is equal to -1. Do you get that? So I had to figure out when dy dx is equal to -1. They gave us the tangent line. They say the tangent line is a line through the origin. So we got a point 0, 0. We know the slope of the tangent line is -1. So what's the equation for that line? What's the equation for that line? Well, point slope form y minus 0 equals -1 times x minus 0. but most everything can figure out is just y equals negative x. Okay? So what I'm going to do is I'm going to take, and I want this equation for this tangent line, I want to find the x, y coordinates for that point P. So this equation, listen, this equation's tangent to this curve, so this equation has to intersect this curve. Alright, now your calculator can't do two variables. It can't graph equations with two variables. So how can I get rid of one of the variables in this equation if I know this equation intersects this?
Can you substitute?
Go ahead, what are you going to say? Somebody's going to say it.
Substitute.
Substitute what?
Negative x.
That's exactly right. Since this equation is tangent to this equation, it intersects this equation, which means let's find the value when y equals negative x. Let's find the value when these two graphs are equal, because that's where the point's at. So I will plug negative x in for every y value here. So I'm going to have negative x to the third. Okay, is that a grass? How did you know to do that? Negative x squared times y. Oh, wait. We're plugging in for y. Times negative x minus 12x squared plus 6 times negative x equals 1. Right there would got you a point on the AP exam. This problem's worth 3 points. It has to be. The first one's 2, the next one's 4, this one's 3. That's a point. Bam, right there. And then solving it for the x value will be a point, and then finding the y value will be a point. So you're going to have 2x cubed, or sorry, negative 2x cubed. This is going to be negative 6x cubed as well. Alright, that'll be minus 12x squared minus 6x equals 1. We can combine these. We're going to get what? Negative 8x cubed minus 12x squared minus 6x minus 1 equals 0. And then figure out where this thing crosses the x-axis with your calculator. Second trace 0 again. You'll get answers. Then we'll take, you don't have to do it right now. We're not going to do it now. So you'll actually take this, plug this into y equals, do second trace 0, figure out where it crosses the x-axis, then take those answers, plug it back in the original, and get your points. So the answer key, I think, let's see what you got. The answer key, and then we'll move on to related rates. So I erased the setting dy dx equal to negative 1, but you actually got a point for identifying that. For knowing the slope of the tangent line is negative 1. Then you got a point for substituting negative x into dy dx. You got a point for solving for the x and y. So after they got that, oh, here it is. This is our version. There was another way to do it. The first version actually didn't have to show dy dx equals negative 1. They had two ways of doing it. So there was another way to do it, I guess. So they set negative x into the equation, solved it, got negative 1/2 and 1/2, and you just use your calculator to get that. Now your calculator will give you the negative 1/2. Okay? So it would have spit out when you took this equation right here, put it into y equals, and did your second trace 0, you would have gotten the negative 1/2. Then you take the negative 1/2 and plug it in the original. The other way they did it is they took the derivative, set it equal to negative 1. What did they do there? So they had the derivative. What was the derivative? Oh, they did this. 4x minus 2xy over, what is it, x squared plus y squared plus 1 equals negative 1. Then they cross multiply and started solving that, and then eventually plug negative x into that one and solved it. Same thing. That was kind of creative too. Any questions? All right, let's spend the rest of the time on related rates. And I've got some for you. So I picked out some related rates like the ones I'm going to do today. Yeah, that's fine. No problem. I do, but I don't know what else. You probably should do it before, because I'd have to go in my storage closet. All right, here we go. Try this one real quick. A spherical balloon is deflated so that its radius decreases at a rate of 3 centimeters per second. At what rate is the volume change when the rate is 7? Go ahead and try it.